Hi everyone, this is lesson 12.1, Find Probability in Odds. So this is the first lesson of the last chapter that we're going to do this year before your air testing, which is coming up the last week of April. So we're going to learn about sample spaces of events, calculating theoretical and experimental probability of simple events. So the notes here says a possible result of an experiment is called an outcome. For instance, when you roll a number cube, there are 6 possible outcomes. You could get 1, 2, 3, 4, 5, and 6. An event is an outcome or a collection of outcomes, such as rolling an odd number. So if I roll a die and ask for the probability of rolling an odd number, that would be a specific event in the outcome. So this says the set of all possible outcomes is called a sample space. So before watching this video, you should have already done the Unit 12 pre-activity, which went over sample spaces and counting how many outcomes there will be in sample spaces. So we're going to go over that a little bit today and also talk about how to find probability. So first example is finding a sample space. So say you flip a coin and roll a number cube. How many possible outcomes are in the sample space? So flipping a coin, you can get heads or tails. Rolling the number cube, you can get 1 through 6. So there's a thing called a tree diagram that can help us organize our sample space here. So you can set up your tree diagram horizontally or vertically. Sometimes I like to do it vertically, but it's really up to you. So, and you already saw an example of this in the pre-activity. So we're going to do heads and then tails, and then I can either choose head, either flip heads or tails, right? And then if I flip heads, then I could either get 1, 2, 3, 4, 5, or 6 on the number cube. So I'm going to go 1, 2, 3, 4, 5, 6, and list 1, 2, 3, 4, 5, 6. And then if I choose flip tails, I could also roll 1 through 6 on the number cube. So I'm going to do the same thing. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So then we would have heads in 1. We could get heads in 2. We could get heads in 3, heads in 4, heads in 5, or heads in 6. So this is kind of how you would abbreviate and list your sample space. So this is our list of our sample space, the abbreviations for the possible outcomes we could have. Or we could get the same thing with tails. So tails in 1, tails in 2, tails in 3, tails in 4, tails in 5, and tails in 6. So if we list all the possible outcomes in the sample space, you see that there are 12 possible outcomes. Now you also learned, there was a question in there at the beginning about the counting principle, the fundamental counting principle. That also states that in order to find the number of outcomes of an event, you can just multiply the number of outcomes in the first event times the number of outcomes in the second event, if it's like a compound event. So if there's 2 outcomes for flipping coins and 6 outcomes for rolling a number cube, then 2 times 6 would be 12. So that's a shortcut, and will also lead to some of the rules we'll be learning in 12.2 and 3. So part B says you flip 2 coins and roll a number cube. So how many possible outcomes are in the sample space? So here we're flip 2 coins. So that means first would be heads and tails. And then the second one, if I do heads, then I can also flip the second one as heads and tails. And if I choose tails, then I can also do the second one as heads and tails. And if I choose heads, I can get 1 through 6 on the number cube. So 1, 2, 3, 4, 5, 6. If I choose heads and tails, I could have 1, 2, 3, 4, 5, 6 on the number cube. And if I choose tails heads, I could get 1, 2, 3, 4, 5, 6 on the number cube. And then tails, I get 1, 2, 3, 4, 5, 6 on the number cube. So if I were to list all of these out, I would do heads, heads 1, heads 2, heads 3, heads 4, etc. So you can do all of that for all of these, heads, tails 1, heads, tails 2, and you can see that if you did all of them, you would end up with 24. And then the counting principle would be 2 times 2 times 6, and 2 times 2 times 6 is 24. So it's good to list out your sample space like this because of other situations, and when we work with compound probability, you need to learn how to write out the tree diagram like this because it'll help with the probability part of it. But actually just finding the number of outcomes, you can use the counting principle. Okay, so another point here is that say you get heads, tails 1. So heads, tails 1, and then also consider the outcome of tails, heads 1. So tails, heads 1. Are these the same thing? In other words, do I count them twice? Do I count the two situations twice, or do I just count the situation once? So although these are the same thing, because it doesn't matter the order of heads and tails and heads, there are still two separate outcomes, because this is saying that the first flip is heads and the second flip is tails. The first flip is tails and the second flip is heads. So they're two separate outcomes, so they'd still be counted in the possible outcomes. But they do still mean the same thing because the order doesn't matter. So that's an interesting thing that we'll get into in the next couple lessons. All right, so probability of an event is the measure of the likelihood or chance that an event will occur. Probability goes from 0 to 1 and can be a fraction, decimal, or percent. So if you write out your probability between 0 and 1, 0 would mean that it can't happen at all, impossible. 1 means that the probability of 1 means that it's certain. It will definitely happen. And then if it's 0.5, that means that it's equally likely to happen or not happen. So that's like a 50-50 chance kind of thing. If you get 0.25, that's unlikely to occur. And if you get 0.75 of a probability, then that's pretty likely to occur. But you'll never know until you find out for certain and do the experiment. Okay, so there's a thing called theoretical probability and experimental probability. Theoretical probability is the outcome for a specific event. So we would call that a favorable outcome. Is the type of outcome that we want to happen. When all outcomes are equally likely, then the theoretical probability of an event can be used. So we just take the number of favorable outcomes divided by the total number of outcomes. So for example, if you find the probability of rolling a 1 on a number cube, that would be 1 out of 6. If you wanted to find the probability of rolling an even number on a number cube, so the probability of an even number, that would be 3 out of 6, because there are 3 even numbers on a number cube out of 6, which is 1/2. But then this is in theory. So if you actually did an experiment, it might look different because it's not always going to be exactly what the theory is. So here's an example. So this says you and your friend design t-shirts with silkscreen emblems, and you are selling the t-shirts to raise money. The table shows the number of t-shirts you have in each design. And then, so these are the number of t-shirts that you have, and this is what is the probability that the student chooses a red shirt. So we would want to know our total number of outcomes. So if you add up the columns, this would be 16 and this would be 14, that would give you 30. If you add up the rows, it should give you the same number. So this would be 18, and then 6 and 6 make 12, which also adds up to 30. So the number of red shirts would be 6, and then out of all of the shirts, which are 30. And then this would simplify to, I'm sorry. 6 is not all of the red shirts, my bad. The total number of red shirts for gold and silver would be 12. Okay, so then 12 over 30 would be 0.4. Now, if I asked you for the number, what's the probability that the student chooses a red shirt with a gold emblem, then yes, I would say 6 out of 30. But this is just asking for all of the red t-shirts, and there are 12 red t-shirts and then 18 green. And then the probability that a student chooses a t-shirt with a gold emblem, well, that would be 16 out of 30, which is 8 over 15. And you can find the decimal for that if you want. Okay, so there are lots of different things that we can do with like a two-way table like this that we'll learn in future lessons. And then finally, you toss a coin and roll a number cube. What is the probability that the coin shows tails and the number cube shows 4? So remember that there were 12 possible outcomes. And then if you roll a tail and 4, then that was just one of the total possible outcomes from our tree diagram. So that would be 1 out of 12. Okay, so experimental probability is based off of experiments, and it will sometimes be different from the theoretical probability. So here we have a spinner, and it's different colors. It's spun 20 times, and this shows the results of the experiment. Which color is the experimental probability of stopping on the color the same as the theoretical probability? Well, the theoretical probability of stopping on any color should be 1/4. So if you're spinning it 20 times, then that would be whatever gets you 5 times, and that would be the red. So the red is spun 5 times, so 5 out of 20 is 1/4, which is the same as the theoretical probability. And then find the odds. Odds is the same thing as just the probabilities. Find the probability against stopping on green. So against or not means the opposite of. And I think we might have learned this at the beginning of the year. It's like the complement. So there are 2 ways to find it. We could take our green and subtract it from the total, or we could just add up everything that's not green. So if you've got 9, if the probability of green is 9 out of 20, then the probability of not green, which you notate by green, and then this apostrophe, the complement, so everything that's not green, would be 11 out of 20, because you would just subtract this from 1. So that'd be the answer to part B. And then finally, what are the odds in favor of stopping on blue? So the probability of stopping on blue would be what out of 20? Well, there was 3, so 3 out of 20. Okay, and that is the end of this lesson. I hope you guys enjoyed it, and have a great weekend.